Hello, good morning, MYP students. I want to welcome you to our third series of Criterion B, where we look at inquiring and designing skills. These are skills you can develop and apply to any situation and any question. Yeah, we saw how to identify variables, which I believe now you are more confident and competent about. Then we also talked about how to design research skills, how to write research skills, research questions rather, and also how to validate them to use that to prove whether it's right or it's wrong. Today I'm going to focus on what we call a predicted guess or an educated guess, what we normally call a hypothesis. We are also going to follow the same trend on how do we write it, and secondly, how do we validate it using the data given to us? So let's go straight into this. We're given a question here. It says that the boiling temperature of water at a standard pressure is 100 degrees Celsius. The table shows the boiling temperature of water measured at different IB schools. IB schools are located at different heights above sea level. The height above sea level is known as altitude, and it can be measured in meters. Okay, then you're given a graph here, which has altitude and boiling temperature of water. Then question one says, using the graph, write down values to complete the table. Okay, the skill we shall learn about in our next video of how do we manipulate data by creating tables, graphs, and etc. I won't go into that today, but our focus is right here. It talks about state a suitable hypothesis that could be tested using the data in the table or the graph as well. So normally the procedure we follow, we use the word if, then we put dash, 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 dash. Then there's something you write there, and then you attach a reason. So the skills we learned earlier are very important here, whereby you must learn how to identify the variables. So the first part of the if, we identify the independent variable. Normally, if you're looking at a graph, the independent variable is written on one of the axes. Could you guess? Could it be altitude or boiling temperature? That's right. It's on the x-axis normally. So the answer would be altitude. And if you observe carefully, it's increasing from 0 to 1,000 and etc. So we shall say, if the altitude increases, then now comment normally on the dependent variable. It is the boiling temperature of water. What are you seeing here? We are seeing that if the altitude increases, then the boiling temperature of water decreases. So what we are seeing is decreasing. Then you attach a scientific reason. You must attach a scientific reason. Normally, this question carries 2 marks. The first part goes for this first part of if and then. The second part accounts for the scientific reason. So the fact that they are giving it 1 mark, they are ignoring the scientific part. Because we know in reality in science that if you go on a higher altitude, like on a mountain, the boiling point in reality increases. But that they have given us, that's not true. Meaning creating a scientific reason may be hard for you or it's unrealistic. So, but normally you can think about creating a scientific reason. Yeah. So here we don't really have a reason we can attach here because data is not correct scientifically. Yeah. Okay, that's how we normally write it. Then for the clue, you can always know if they put 1 mark, then you get to know they want to focus on the scientific reason. But if you can put it there, better. Then the other part that you need to develop is validity. You must learn how to validate whether your prediction is true or it's wrong based on the data given to you. So we are given a question here which says that common salt is used in cooking, but many other salts also have important uses in food. The table shows a list of salts used as food additives. their taste, and their food uses. Okay, there are salts here. These are salts. We have their taste here and other uses. Using the information from the table, a student hypothesized, predicted the salt test of salts is caused by presence of group 1 ion. So we'll just look at the salts here. This salt is testy, 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 testy. So all of them are testy. And they're saying that the reason why they are testy is because of the group 1 ion. So identify the metal in group 1. Now, let's begin from here. Look at sodium. Is sodium in group 1? Please check in your periodic table and let me know. Yes, that's true. So the sodium ion is in group 1. And because we have this group 1, which is sodium, and is salty, that part is true. As of now, our hypothesis is true or valid. Let's look at potassium. Please confirm. Normally, the first one they mention is the metal. Is potassium in group 1 as well? Oh, yes, that is true as well, meaning our hypothesis is also correct. Let's go on. Look at magnesium. Check for magnesium. Which group is magnesium? Oh, magnesium is in group 2. So the fact that it's in group 2, but still the salt is testy, then you know that the hypothesis is not valid. That it's not valid. Therefore, okay, like us to continue from where we stopped. So yes, the fact that magnesium is in group 2, but the salt is still salty, then we know our hypothesis at this point is not valid. So the first mark you get is concluding whether it's valid or not. So we are saying not valid. Not valid. And the reason we are seeing magnesium. So the other reason we are seeing magnesium, which is in group 2, but the salt is salty. So that makes it not valid. Despite the fact that we had potassium and sodium, which were in group 1, which were making it become valid, salty, but there's magnesium here. Then observe, we have calcium. Check calcium. Which group is calcium on the periodic table? That's correct, it's in group 2. The fact that it's in group 2 also means that our hypothesis is not valid. So the other mark we are seeing here is calcium ions. They are in group 2, but the salt is still salty, meaning it's not valid. Then look for ammonium. This ammonium is not even a salt. It's actually a compound. Ammonium ions look like this. So it has a name, we give it, but not for today. The fact that we have an ammonium compound here, an ammonium ion, which is not in group 1, but still it is salty, then we shall know our hypothesis is not valid. We have 3 reasons. We have magnesium, we have calcium, and the ammonium ions. Then space of what is making it become salty? Can you look carefully? What do all these salts given to you have in common that's making them salty? So read each of them and see. That's right. They all have a chlorine at the end, what we call a chloride. So the answer would be that what is making the salt salty is because of presence of chloride ion. So the other 4th mark you can get telling us that we have discovered from the information all the salts have chloride on them or chlorine on them, and they are all salty, implying that the cause of saltiness is chlorine. So you discover that this kind of concept, maybe no one taught it to you in class, but the knowledge on how to validate a hypothesis is what you have been applying here by reading carefully and identifying patterns. But also having knowledge of science on how to use a periodic table was very important in this kind of work. And that is how we validate. So we conclude here it's not valid, and you give your reasons. In other questions, it may be valid and you give reasons. So don't promise it won't always be valid. It can vary depending. Thank you for listening. We'll catch up in our next video. Have a good day. For any questions, please reach out to me. And as well, there's a link for you to answer a Google form for practice. Please fill it in and get prompt feedback in the link. Have a good day.